One of my students requested a boiling point elevation video, so I put this problem together. We'll go through it step by step, and I'll explain some of the skills you need to have to be able to do this. There is some assumed knowledge here. I'll try and point that out. Let's read it together. What is the boiling point elevation when 13.5 grams of iodine is dissolved in 120 grams of carbon tetrachloride? So first of all, I'll point out there's 3 significant digits here and 1, 2, 3 because of this decimal here. So our final answer should also have 3. Then there's a second question. What is the boiling point of the solution? And then finally it gives us a piece of information. The constant for the boiling point elevation for carbon tetrachloride is 5.02. Now, if you're in a chemistry class that doesn't give you the formulas for some of these more obscure formulas or compounds, you may have to know how to decipher this from the naming chapter that you've gone over of carbon tetrachloride for naming molecular compounds. So there's a couple pieces of knowledge already there that might be assumed. It's also assumed that you know the equation for this, so we happen to know that. The change, delta means change, and boiling point, so T sub B, is going to equal the constant multiplied by the molality. That has this funny M symbol. And molality is just a measure of concentration. So if we're looking for this, we can see right off the bat we already have one of the variables. So if we can just find this, we can solve for delta TB. So what is molality? Well, molality equals moles of solute over kilograms of solvent. So we don't have these numbers yet, but we can get them from up here. So that's what we'll do next. For example, let's just attack these one at a time. So moles of solute the solute is going to be what gets dissolved, so we can see iodine is dissolved in the carbon tetrachloride. So this is the solute, and it's 13.5 grams. So we need to convert this into moles. So we'll just do our handy conversion here. And we need the molar mass for this. This is another skill that you would need already to be able to do this problem. So iodine is an diatomic molecule when it's in its elemental state. What that means is for every 1 mole of I2, there's 2 of them. So when we look up the molar mass on the periodic table, we're going to have to multiply that number by 2. And I already did this ahead of time. And so the molar mass of iodine is 253.8 grams of iodine, or I2. So we do this math, punch it into the calculator, and I can do that really quick. So I'm going to just take 13.5 divided by 253.8, and this is going to be 0.0532 moles of iodine. So we've got this number, and I'm just going to plug this in right now because this goes up over into this equation right here. So I'm just going to extend this out and say moles of the solute equals 0.0532 moles of iodine. Now let's tackle the bottom, the kilograms of solvent. This is much easier. It's a more basic equation or basic conversion. So we have 120 grams of carbon tetrachloride, CCl4. So I'm going to again do a conversion, and I know converting grams to kilograms, there are 1,000 grams in every 1 kilogram. So that will cancel. Notice that grams canceled here too. And I will just complete this. 120 divided by 1,000 is going to be equal to 0.12. Now notice you have a significant digit here, so I'm going to 120 that to make sure I've got this correct number of significant digits. This then is going to go up into this equation as well right here. So that's our kilograms. I should write my units there, sorry. So 0.120 kilograms. So now I can simply divide this. I've kept my answer in here. So divided by 0.12 equals 0.443 molality. So now that I have the molality, I have this one. So now I can take this and plug it into that one. So we can just extend this out. So KB, this was the number for that. So 5.02 degrees Celsius per molality multiplied by 0.443 molal, is the shortened name for that. And my molality will cancel out, and I'll be left with degrees Celsius. And so this will equal 2.23 degrees Celsius. So that will be my boiling point elevation. What is the boiling point elevation? However, there was a second question. What is the boiling point of the solution? Well, I looked up carbon tetrachloride, and in pure carbon tetrachloride, the TB for pure CCl4, is 76.72 degrees Celsius. So if you're elevated by 2.23, we simply have to add those together. So the TB for the solution is 76.72 degrees Celsius plus 2.23 degrees Celsius. And we add that together and we get 78.95 degrees Celsius. So this would be the second part of the answer, and that completes the problem. Thanks for watching.